Hello and welcome to another in my video tutorial series over different concepts and information for preparing you for your CompTIA A+ certification exam. In this lesson, I'll be talking about supporting hard drives and other storage devices. We're trying to get away from, or at least some of us are trying to get away from saying hard drives, and it's a little difficult, but with having solid-state drives as being the device of choice, it's still hard when we're talking about storage devices to say storage device and not hard drive. I mean, I know we have other storage devices such as flash drives and tape drives. Optical drive is obviously a storage as well, but the media itself is. But let's just wrap all that up into this lesson here, and we'll discuss different technologies that are used inside the hard drive and how the computer communicates with a hard drive. Some general information on installing and supporting a hard drive, talking a little bit about the different storage technologies, and a little bit of troubleshooting. Let's go ahead and take a look at some devices now. First of all, we will take a look at the spinning disk, the hard disk technology. We have different sizes of these. We also call these HDDs. So you'll hear them referred to hard disk drives or HDDs. And you might even hear the term spinning hard disks or spinning disk drives. So there's lots of terms for the same technology. And I've got three different sizes shown here. On the left we have the standard or relatively standard for our desktop computers. That is the 3.5-inch size. And this one is using, we'll be using SATA technology for our connections. You have the 15-pin SATA connection and the 7-pin SATA connection. The 7-pin SATA connection is for your data, and you can see that here in this section here. That is our 7-pin, and you can see that's denoted as an L shape. So when you're making the connection from your SATA data cable to the SATA port on your hard drive, you will need to put it right there for making sure that the L shape is in the same orientation on both pieces. Next we have the 15-pin power SATA connection here. So on your power connection coming off your power supply unit, you will need to use that 15-pin to provide power to the hard drive in that location with the same orientation of the L in both devices. Alright, we also have the laptop standard size. That is here. That is 2.5-inch size hard drive. And that is typically what you will find in your laptops. You can put these in a desktop. You'll just need a 3.5-inch adapter sled to put that on so that you can mount that in. It's the same SATA connection, same size SATA connection for your 7-pin data and 15-pin power. So the same technology, nothing's changed there, it's just the size is different for the device. And then on lower end laptops and some small form factor computers, you will have this 1.8-inch size hard drive. Now when it comes to this hard disk drive, we also call this a magnetic hard drive. Now there's lots of parts to this type of storage technology. You could have one, two, or several platters or disks. You can see those here in those spinning disks. That's why we call it a spinning disk drive sometimes. But the correct term is a platter. These are stacked together, spinning in unison, and they're inside a metal housing. So they are contained. So this is just one that's been taken apart for you to be able to see. And there's firmware for this that controls the reading of the data, the writing of the data, and any type of motherboard communication. Now we also have read-write heads here that are going to read the data off of the platters or write the data to the platters. We have our actuator arm. So there's a lot of different parts here. But the actuator is going to control those read-write heads. And when it comes to how data is stored here, data is going to be organized in concentric circles, and we're going to call these tracks. And then these tracks are then divided into what's called segments or sectors. So if you've ever heard someone use the term, oh, there's a bad sector on the hard drive, that's what we're talking about. And then when it comes to these sectors, most of the current hard drives are going to use 4096 byte sectors, or 4096 byte sectors. We also have hybrid hard drives that use technology that's beyond this. It's like a cross between a spinning hard disk and a solid state drive. But before you can use these on your system, make sure that your operating system supports a hybrid drive. And the last part I'll talk about here on the spinning hard drive is the drive spindle located in the middle here. So just to go through it once again, we have our drive spindle, does the rotating. We have our platters here. We have our read-write heads. And then we have our actuator. So these are the parts that have to do with a spinning hard drive. Now we talk about a solid state drive. These are really the preferred technology for our systems, whether it be a laptop or a desktop computer, because they're much faster. There are no moving parts, so there's less things that can go wrong. We're not worried about a spindle getting scratched. We're not worried about the read-write head getting broken or damaged. This is just like your thumb drive technology or your flash drive technology that you're used to using. So it's much faster, less power consumption, and they are just much more efficient. These solid state drives, or SSDs, you might also hear it called a solid state device. They're built using non-volatile flash memory stored on an electronically erasable programmable read-only memory chip. Or you might just hear it called an EEPROM or EEPROM chip. So that's non-volatile flash memory. So when we lose electricity, we don't lose all the information that's on the device like we do in random access memory or RAM sticks. The memory that's used in these SSD is called NAND flash memory. Lastly, I'll talk about is the lifespan of our solid state drives, and we base our lifespan of a typical SSD on the number of write operations to the drive. So a really large number of times that you're writing data to this device. That's how we determine the lifespan of this. These are typically a little bit more expensive still. They still haven't really caught on for everybody yet. So it's still expensive technology, but it's much faster. It's a lot more reliable than a hard disk drive. They last longer and they use less power than those magnetic drives. So definitely a plus. And I think if you haven't used one and you use a device that has one, or make the change and change out your old hard drive and put in a solid state drive, you will be much happier and you will jump on this technology and never want to go back. As you can see, these solid state drives use the SATA interface standards. As I mentioned earlier, the 7-pin and the 15-pin. When it comes to SATA, there's different types of SATA standards. You have SATA 1, or you can call it SATA Revision 1, or the original SATA. You have SATA 2, SATA 3. There's different technologies, but for the A+ certification, you only need to know up to SATA 3. And with each new standard, the main part that's different is the data transfer rate at which the data flows. With SATA 1, we have a data transfer rate of 1.56 gigabytes per second. When we go up to SATA 2, we double that, and we now jump up to 3 gigabytes per second for the data transfer rate. And then you guessed it, when we got to SATA 3, we have a data transfer rate of 6 gigabytes per second. When it comes to our serial SATA standards, this supports hot swapping, or you might even hear the term hot plugging or hot unplugging. This is where we can connect and disconnect a drive while the system is still running. I already mentioned that we use a 15-pin SATA power connector and a 7-pin data cable connector. And our motherboards on our systems might have anywhere from 2 to 6 or even more SATA connectors on your motherboard. When you're looking at your motherboard, make sure you use the connectors in the order recommended in your motherboard user guides. You may need to look this up. But typically, most of us, we'll look at the motherboard, see the numbers. you can typically kind of figure out on your own, but for best practice, use your motherboard documentation to know which order to put your SATA connectors in. Usually your motherboard or an expansion card can provide external SATA ports for external drives. This is called eSATA. And you can see the port there on the left side of this external device. This is an eSATA. eSATA drives use special external shielded serial ATA cables that can be up to 2 meters long for their data connection. SATA standards for the drive and the motherboard need to match for optimum speed if you're going to be purchasing a SATA device. Just like with anything in IT, you're only as fast as your slowest component. So if you have a SATA 3 device and your port will only support SATA 2, you're only going to be at that 3 gigabytes per second speed because you're going to match the slower speed for your data transfer rate. When selecting a hard drive, your hard drive must match the operating system and motherboard. You need to know what standards the motherboard or the controller card are providing for your drive interface to be able to be usable. Your UEFI or older BIOS is going to use auto detection to prepare the device. So the drive capacity and configuration are then selected, and the best possible standard becomes part of the overall configuration. Some of the considerations you have: drive capacity. Some of today's hard drives are in way up to like 6 terabytes for our magnetic hard disk drives. Just know that if you're using a hard disk drive, the larger capacity you go for your drive, the longer it's going to take when you have to do your defragmentation process. And remember, when using a solid state drive, never ever ever run defrag on that drive. You also need to consider your spindle speed if you're using a hard drive. The higher the RPMs, the faster the drive. Whether you're using a slower 5400 RPM drive or you're going up to a 10,500 RPM drive, spindle speed is one thing to consider when you're selecting the hard drive that you want. When you see these deals that come out in flyers for cheap computers, typically you're going to have the very slow 5400 RPM hard drives in there because it's more cost effective for them to be able to put that out instead of a better performing hard disk drive. You need to obviously use the standards for your motherboard, what it supports for selecting a hard drive. You also need to think about your cache or your buffer size, and you obviously want the larger buffer size. You know, a 2 megabyte buffer or cache is not that much, so make sure you're paying attention to that too. When it comes to installing your drive that you've picked, look at how it was originally inserted. If you're replacing, if you have never installed one, then you might look at the documentation that comes with the drive or go online and look at some videos of how to install that type of drive in your system. Your manufacturer is going to provide, usually on their websites or in a PDF user documentation, how to swap out a drive, because these are field replaceable units, or FRUs, or field replaceable devices, FRDs, whatever the case may be. These are parts that the manufacturers have determined, hey, the typical person can change these out. So think about that. If you're ever taking a PC in, or you heard of someone taking a PC in and they've had their hard drive replaced, ask them how much it costs. It's a very simple process for you to do on your own. And as future IT technicians, this is a must in knowing how to swap these out, making sure you are using the proper connections. You obviously can't use an old IDE connector onto a modern SATA connector. If you are installing a hard drive and say you're replacing one, back up the data off of the existing one. If that's not the reason that you've replaced it, is because it will no longer work, then you can back up the data. If not, obviously you can just put in the new hard drive and install your operating system and get up and running. If you are wanting to see if you can get some of the data off, you might need a USB to SATA converter so that you can copy files from one another. And you can look those up on like Newegg or Amazon or other sites for getting one of those USB to SATA converters. A hard drive kit is definitely something you should have in your IT toolkit. When it comes to installing a hard drive in a laptop or a storage device in a laptop, some are easier than others, so it depends on the manufacturer. Some may just have a screw or a couple screws that you take out, and then you can then slide the whole drive out, and it's just got a little enclosure around it that you can pop off and then put your new drive in that tray, slide it back in, put your screws in, and you're done. Some you might have, I've had them where I had to take out the whole motherboard to get to it. Some of them you can just take the bottom cover off and then simply take a couple screws out, slide the drive out from the inside, and put a new one in. Just repeat in the opposite order of taking it out. Make sure you have no spare parts. Okay, now let's talk a little bit about RAIDs, or redundant array of inexpensive disks. And you can see I just put redundant array of ID because people call the ID different. Some people might call this a redundant array of independent disks. Another person might call it a redundant array of inexpensive disks. This is just a technology that configures multiple hard drives to work together as an array of drives, so as a team of drives. So why would we use RAID? Well, we want to improve fault tolerance by writing more than one copy of the data to a different hard drive. We want to improve performance by writing data to 2 or more hard drives so that a single drive unit is not excessively used. So we have fault tolerance and performance. Those are the reasons we use RAID technology. We have what's not really a RAID, but it's a type of RAID that's just called JBOD. And this just stands for just a bunch of disks. This is where you're spanning the data. You can use 2 hard drives to hold a single Windows volume. So when one drive is full, the data simply spans over onto the second drive. But if a drive goes bad, all the data that's on one of the drives, the one that went bad, is lost forever, especially if you don't have your data backed up. The other one we have here is a RAID 0. This uses 2 or more physical disks. Now these do not have to be hard disk drives. You can use other drives as well. But with the RAID 0, we're going to write 2 physical disks. We're going to write the data evenly across all the disks so that one disk receives the same amount of activity as another. So not one disk is going to receive all the activity. So we also call this RAID 0 as a striped volume. So this is where you hear the term striping. We're striping the data, putting slashes of the data across multiple drives. With RAID 1, we call this mirroring. This is very simple to remember because we're simply duplicating the data on one drive to another drive, and we use this for fault tolerance. If you remember what I said fault tolerance is, that's where we have more than one copy of our data. So we will call RAID 1, you call this a mirrored volume. So RAID 0 is striping, RAID 1 is mirroring. Now what about RAID 5? RAID 5 is going to use 3 or more drives, and this is going to stripe data across the drives and uses a parity checking bit so the data is not duplicated. And then we have RAID 10, the best of all worlds. This is a combination of RAID 1 and RAID 0. This is going to take at least 4 disks to be able to set up a proper RAID 10. Some people call this a RAID 1 plus 0 or a RAID 1.0. Most of us just call it a RAID 10. So the data is mirrored across pairs of disks. So we're mirroring the data and we're putting that data on multiple disks. So if we have a disk that gets lost, we still have the data. So we have fault tolerance and we have improved performance. Now if you want to implement a RAID on a system and you're going to have Windows installed, RAID must be implemented before Windows is installed. So if you ever set up a server, this is one of the first things that when you start up setting up a server, you're going to be asked to do. Do you want to set up a RAID? If so, what kind? And then you get that set up before you move into doing an operating system. But if you're doing this on a desktop, let's say at home, make sure that you set up the RAID, implement that in your BIOS before, or your UEFI, before you put an operating system on the disk. Now a little information about tape drives. This is an inexpensive way of backing up a hard drive. This uses worm technology, or write once, read many. This assures data is not going to be written, overwritten, because the data that's written there, that's the only time it can be written. It can never be written over. The disadvantage of tape drives is that data is stored in a sequential access. So to read the data from anywhere on this tape, you must start at the very beginning of the tape and keep reading until you find the data you want. It is extremely slow. It's inconvenient. I do not support tape drives at all as a way of backing up information. I would look at using cloud backup as well as a type of electronic digital backup. There's lots of devices out there. Even if you're using a solid state drive in solid state drives in external cases and you're putting this in the bank vault, that's much better than a tape drive. And if your tapes go bad, your tape drive goes bad, now you're looking at a really critical situation of, oh, how do I use that information if that's no longer an option for me to be able to buy? But if you do have to use a tape cartridge, some of those common types of tape cartridges are DDS or digital data storage, linear tape open, that's LTO, DLT, which stands for digital linear tape. You also have super digital linear tape, Travan. So there are options if you must go down that route. And I know a lot of first gen IT guys still believe in tape drives. I'm just not a fan. So that is up to you, but you do need to know a little bit about that as a method of storage options when it comes to your A+ certification. Though some of this technology is coming harder to find, we do have optical storage as an option for our data storage. Because this is a dying technology, some manufacturers have stopped making the media. So it's still an option. You still need to know it for your certification exam. So let's talk a little bit about that. We have CDs, we have DVDs, and we have Blu-rays, and that is misspelled on purpose. Blu-ray discs have the largest capacity, but we still need to know about other technologies. CD drives use CDFS or compact disc file system, or they may use the universal disc format file system like DVDs and Blu-rays use. Blu-rays and DVDs use universal disc format, but the CDs can use either. When it comes to these technologies, this uses a laser technology. Tiny lands and pits on the surface of this optical media represent bits read by a laser beam. It's that simple, and that's where we use that technology, and that's why your optical drives do have that laser technology in them. When it comes to writing this data on this media, on a CD, we can only write to one side of a CD. Now, one or both sides of a DVD or digital video disc or Blu-ray disc can be written on. And they can hold data in different capacities. With your CD, your capacity is 700 megabytes of data. With DVDs, we have single layer, we have dual layer, so we can have 4.7 gigabytes on a single layer disc, or we can have 8.5 gigabytes on a dual layer disc. There are some double-sided single layer discs that and double-sided dual layer discs that can go up to 15.9 gigabytes. And then with our Blu-ray disc, we have a double-sided single layer that holds 25 gigabytes of data. So you see a much larger jump from the standard dual layer DVD of 8.5 gigabytes all the way up to 25 gigabytes. That's a lot of data we can store on that single disc. And then if you have a dual-sided dual layer Blu-ray disc, this holds up to 50 gigabytes of data. So very large amounts of data. And typically your lifespans on this type of media last up to about 50 years of degradation before they break down. So you have lots of options. We also have flash drives for storage, lots of media and lots of storage devices we have available to us in the IT world for storing our data. Troubleshooting our storage devices can be a lot of problems. We have lots of different things we can look at. As an example, problems caused by hard drives during the boot can be caused by a hard drive subsystem. The file system on the hard drive can be corrupted. Maybe there's a problem with the actual physical hard drive itself, because as I said, those moving parts can be damaged and we have to troubleshoot that. With our spinning hard disk drives, perhaps you're seeing slow performance. As I mentioned earlier, you might need to run the defragmentation tool on your hard drive only on spinning hard disks, and this kind of brings all that fragmented data, pulls it all back together so that it can be read more sequentially rather than having to look at many different places to find that data. Hard drive problems from the hardware, those usually show up on your post, so your power on self-test. And this could be due to the drive cable itself, the electrical system, the motherboard, or loose connections. So there's lots of things to check. If you hear it clicking, that's usually a good sign that your spinning hard disk drive is failing. It's time to get your data backed up before it fails, and then replace that hard drive, which my preference obviously is a solid state drive, but definitely get that drive replaced soon. There is different software that you can use for diagnosing hardware problems with your hard drive, so make sure you can use those. Find something that works for you. Well, everyone, that's all I have for supporting hard drives and other storage devices. This is a very wide topic. You need to know about the different media, the different storage devices, and the speeds, the connectors. Make sure you know all this going into your A+ certification exam. Thank you for following along, and I hope you found the information helpful. Good luck, everyone.